and functions. He had finished the entire theory part, and I asked sir, and today we will do one more class on that topic, but no more theory. We will look into JE Advanced or JE Main style problems, because that will give you a general idea of how the ISI prelims problems might look like. Okay, so we will look into those problems, and definitely from the next class we'll start a new chapter. All right, since this is the class right before the puja vacations, many people will not be attending, so there is no point starting a new chapter, but we can do quite a bit of problems. All right, so last day, let me just quickly go through what we had done last day. I think we had ended with periodic functions, if I remember correctly. So periodic functions, and then we had also done a few problems on odd even functions. So hopefully all of you have received the notes as well. I had sent all the copies to the organizers, so they must have given you the notes. If you did not receive them, do drop a text in the chat box. I'll look into it. All right, so yeah, last day we looked into all of these, right? We looked into odd functions, even functions, the algebra of odd functions. Okay, and we also looked into, yeah, so we looked into a few sums, how they work, and so on. And at the end, I think we discussed periodic functions. All right, some properties of periodic functions, how you can solve problems of periodic functions, and so on. But this entire chapter, we did blocks of theory and then a few problems. All right, but remember, when you get these problems in your exams, they will be randomized. Okay, so you'll get one problem from some section and then one problem from a different section. So we will just do questions that are random. So I'll start with okay, so this chapter is named sets, relations, and functions, right? So I'll start with a few problems of sets, because the problems from sets are a little bit different than the problems with functions. Majority of you have done a few problems on functions at your school level, but usually sets are the topic that gets ignored. All right, so I'll start with a problem from sets. I'll not do those properties from Venn diagrams, right? Because those problems have stopped appearing in exams. Like, I have only seen them in government exams so far. In ISI level problems, they were there like 7 8 years ago, but I don't see them recently. So we'll just do normal set based problems. Try this one.
सर ऐसा क्वेश्चन एमएस स्टैट में आता है या एमबीए स्टैट में आता है सर?
हाँ जी, हाँ जी।
तो सर ऐसा क्वेश्चन एमएस स्टैट में आता है या एमबीए स्टैट में आता है?
बी स्टैट में आता है। एम स्टैट में मेजरली आपको कैलकुलस वगैरह के क्वेश्चन आते हैं। ठीक है, जनरल क्वेश्चन बहुत कम होते हैं एम स्टैट में। मेजरली आपको ग्रुप्स, रिंग्स, फील्ड्स, वहां से क्वेश्चंस, फिर एब्स्ट्रैक्ट अलजेब्रा से क्वेश्चन, कुछ क्वेश्चंस आते हैं, रियल एनालिसिस से बहुत ज्यादा क्वेश्चंस आते हैं, और बाकी सब कैलकुलस। ओके, मल्टीवेरिएट, सिंगल वेरिएट, ग्रीन थ्योरम, वहां से आता है। Try solving each part. All right, you have three conditions here: A, B, and C. You will have to solve the three equations. Okay, try doing that. Once you are done, tell me what is A, what is B, what is C. If that is wrong, then of course your calculation will be wrong. So check each subpart. Tell me the answers, I'll verify. Yes, what is the solution of A?
Sir, is it greater than 3?
There is a modulus, right? So you'll get both sides. Greater than 3 is one side. What is
Yes,
the other?
less than greater than 3. That is what it's coming.
So what will you write in the interval form?
From negative infinity to 1 and then union with 3 comma infinity.
Yes, correct. So A is equal to minus infinity to 1 union 3 comma infinity. Yep, fine. Go on, do B.
So that should be negative infinity to negative 2 and union with 2 to infinity.
Negative infinity to negative 2 union 2 to infinity. Fine. Go for C. Others, I hope this is clear. Yes, yes. Someone has
I'm doing
answered.
the complement at once.
First calculate A, B, and C, and then do the complement. I mean, then do the intersection and take the complement. Because when you do the intersection, it will reduce the complexity of the calculation. Do not try to apply De Morgan's laws. That will be a bit more complicated. Or will it be easy? So if you do via De Morgan's law, A intersection B intersection C complement, this should be equal to A complement union B complement union C complement, right? Well, I have a doubt in this. I remember De Morgan's law working for 2 sets, but for 3 sets, I do not think this works. All right, so let us not do it right now. I'll have to confirm this. Try this one, this method only. It should work. So we will calculate the intersection. The intersection will be very small. Okay. Try. I had this solved normally, but De Morgan's law is a good shout. I'll check. Let me know when you have done C.
So C is coming out to negative infinity to 2, including 2, and union with 6, including 6 to infinity.
So C is minus infinity to 2 closed. Union 6 to infinity. All right. Now find
sir.
out the intersection. The intersection should not be that tricky, right? So this is up to 1, this is up to 2. So of course this is close to. So what will be the common thing on the left hand side?
Negative infinity to negative 2.
Negative included or excluded?
Excluded.
So negative infinity to negative 2. Yep. What about the right hand side?
6 to infinity with 6 included.
Yes. So now do the complement. So A intersection B intersection C complement. This will just give you minus 2 included and 6 closed, right? Sorry, minus 2 included and 6 open. Everyone agrees up to here? What is A intersection B intersection C complement? We don't need to write this large thing once again. So we basically need to know what is minus 2 comma 6 intersection Z. What will this be? Basically, how many integers are in this interval?
The set itself would be the intersection.
Be careful. 6 is not included there. So you will write minus 2
Minus 2,
minus.
minus 1, 0, 1, 2, 3, 4, 5.
Yes. So how many are there?
8.
Yeah. So number of subsets?
2 to the power 8.
Very good. Which is?
256.
That is the correct answer. Okay, so not very difficult, but not very tricky as well. Sorry, but not very easy as well. All right. You had to do multiple sums in one sum. Now we had done all of these subparts under when we discussed modulus function. All right. So all of these got compressed and some properties of set also came in. All right. So you will get sums like these. We'll do one more of this type. Let's see if you can figure it out. Try this one. Yeah. How do you do this problem? So again, we'll have to figure out what A is, right? So n is n square less than equals to n plus 10,000, right? So what do we have? For A, we have A is
And
basically,
any natural number above 101 equal to or 100 and above 101.
yeah, I don't, yeah. What? Go on again.
100 square is 10,000, and
Yes.
that's not gonna be included in this since 100 plus 10,000 is 10,100.
No,
It's
not
greater
like that.
than 10,000.
We will do it like this. So n into n minus 1 is less than equals to 100 square, right? For A, this is the criteria that we have, right? So what does this mean? This means A is from 1 to 100. It belongs to natural numbers, right? You cannot have 101 here, because if it is 101 into 100, it will be 10, right? That won't work. But 100 into 99 will work, because that will be
My bad, I
9900.
did the opposite.
Yeah,
I did the
exactly.
opposite.
Yeah. So
That
A
was
is
a
1 to
functional
100.
number.
Everyone agree?
So we could also just make it a quadratic equation n square minus n minus 10,000 is less than or equal to 0.
Yes. Will you be able to solve it in a reasonable amount of time?
No, that is slightly longer.
Yeah. So will 10,000 factor? I don't think it will factor, right?
No, but like it
No.
will come out to 40,001, which is you can take rough values, but it will be longer.
Yeah. Plus a calculator will be much more beneficial there. You can do it that way, but since these are natural numbers, right? We don't need the exact range of values. For natural numbers, it is quite easy to do the calculations because we can exclude all the intermediate points. So if we do that, we'll get A equal to 1 to 100. Now, what about B? So B is basically
So it'll be
3k
all
plus
natural numbers other than 1, 2, 3, 4.
1. For B,
Yeah.
no.
Yeah.
B is just a simple AP, right?
Like 4, 7, and so
Yes.
on.
4, 7, 10, 13, so on. See?
Wait.
Like
Okay.
C is
all
just
I
even
2,
am
4.
numbers.
seeing it.
Yeah. 2, 4, 6, 8, dot, dot, dot. Now what do we need? The sum of all elements of the set A intersection B minus C. So what is this? What is B minus C?
So it would be the all odd values in set B.
All odd values in set B. Yes, very good. And what would they be?
7, 13, and so on.
Yeah, fine. So B minus C is basically the values remaining in B after removing the common elements from C. So this is 7, 13, then 19, and so on. What is A intersection B minus C?
All those values which are less than 100.
Yes. So what will be the last value here?
97.
Fine. So what do we need? Then sum of all elements, right? This is done. N by 2 into A plus L. All right. You'll have to find N first. So to calculate N, what would you do? 97 is equal to 7 plus N minus 1 into 6. Find out what is N.
16.
16.
Yes.
All right. Now calculate the sum.
832.
Yes. These are not very difficult sums, right? But you just need to get started with it. All right. So This was a combination of AP and sets. All right. Of course, you will never get the problems of sets as standalone problems. Well, sometimes you might get, but those will be theoretical questions then. You will find those in ISI quite often. There'll be theoretical questions where you would have to prove something relating to sets, usually via the union, intersection, or the De Morgan's laws. All right. So let us do one of that type of question. A theoretical set based question.
Sir, over there is it 16 by 2 into 17 plus 97 or 7 plus 97?
7.
Okay. So is the answer D?
Yes. D is the answer. How do you do it?
I just proved the other three correct.
Hey, that
I could
is
not find a way to prove that wrong, so I proved the other three correct.
Arre baapre, that will take a lot of time. For this, you draw the Venn diagram. Okay. So what does it say? It says A intersection B is not phi. All right. So that means there is a point of intersection between those, right? So if I take A and if I take, whoops, if I take B, so their intersection is not phi. So that means this, there is something here, right? So A, B. Now what do you have to do? It says this intersection is inside C. So I can just do something like this. Wait. Yeah, that makes sense. So if I do this, then every condition is now satisfied. This is C. All right. So
But your parts of A and B are also in C. Is it just
not a problem. It says it's a proper subset. Sorry, improper subset, right? So that means A comma B can be equal to C. A intersection B can be a subset of C and can be equal to C as well. So we'll always take the larger case. All right. Do not take the most specific case. That will be a problem.
but
Okay.
nowhere it's given that just A minus B or B minus A portions of that can also be in C.
No. Is it given that it cannot be the case?
No.
You say that it
Okay.
can be the case, right? That is absolutely true. Nowhere is it given that it can be the case. But is there given that it cannot be the case? If not, then we will consider the largest possible case. All right. Consider every possible case. If I make it just so that it fits that intersection, then that will be a problem. Okay. So you were saying, if I understand correctly, that C could be just this, right? C could be something like this as well. C could be something like this as well, right? But in all of these cases, we lose some part of generality. So when A intersection B belongs to C, we will draw the most general set possible, which is this one. So every part gets included here. Okay. Now we try to disprove the other cases. Now it becomes easy. So what is the first part? B intersection C not equals to 5. That's not true. See, whenever it says which of the following statements is not true, there is a hidden word here. It means which of the following statements is not always true. Okay. So can you draw a set C such that none of these statements not true, right? So you have to draw C in such a way that that the correct answer from here will never be true under any circumstances. All right. So we drew C in the widest or the general most way possible to show that there could be at least one imaginable scenario in which the correct options will get eliminated and we will get the wrong one, because we have to pick the wrong one, right? The complementary one, the not true one. So B intersection C equal to 5, possible. If A minus B is in C, A minus B is this part. That is a subset of C. Yeah, fine. Then A is in C. A is a subset of C. Okay, so what about this? Case B. Case B is a bit
Yes,
different.
sir. It's
Yes.
possible because we already know that A intersection B is inside C. And
Yes.
now we also know that the other part, which is other than A intersection B for A, is also inside C. Hence, the
Then
entire
the
set A
entirety of
is
A will be C. Yeah. So I don't need to draw a separate diagram for you. I hope all of you have understood this. A intersection B. The common part is in C, and A minus B. The other part is also in C. So of course the entirety of A will be in C. Very good. B done. C union A. All right. So this entire part. Intersection C union B. So this entire part is equal to C. Yeah, that makes sense, right? That of course makes sense. So if 3 of them are correct, answer option 4. If A minus C belongs to B, then A belongs to B. Well, A belongs to B is a difficult proposition here, right? A minus C means the part that is not in C but in A. If this is in B, then A belongs to B. No, because this is not equals to 5, right? Cannot happen. Okay? Because if entirety of A is in B, A intersection B will be the entirety of either B or A, right? That is not equal to 5. Check. See if I got this logic correct. Anyway, if all these 3 are wrong, then D will be correct. But do check if you all understand D.
Yeah, sir, we can just say that it cannot be shown that B is inside C entirely.
There is no guarantee of that. Yeah,
Of
that's what
course.
you're saying. That there is no guarantee that B will be entirely in C.
Yeah.
Yeah, correct. Because if B is entirely in C, A intersection B will be a problem. That condition will suffer. I think that will happen.
Wait, I lost my thought process. 1 second.
Yeah, try to think it.
We can say that A will be inside C. In that scenario, A intersection B is also inside C.
We have to basically form another Venn diagram that shows that this statement is wrong, right? So what if we encircle A and B? Let's say I do something like, oops, not this. If I do something like this, then what happens? So then this will be A, this will be B, and this entire larger rectangle is C. Then check option D will get violated. I think that will happen. Let us go through this. A minus C. A minus
Complement.
C. Yeah, basically A complement. Yeah. So A complement will be this part. This part
In A
is,
complement, one part of B is missing itself.
yes,
Hence, it cannot be a subset of B.
correct. In A, this is the entire A complement, right? And this is not inside B. Yeah, fine. That works. So if you draw only one Venn diagram, you can eliminate the 3 options. So it is clear that A intersection B not equals to 5 and A intersection B belongs to C. A minus C, that is A complement. A complement will be 5, right? A minus C, that means all the parts of C that are not in A. Every part of C is in A because C is the superset, right? So every part of C is in A. A minus C will be equal to 5, belongs to B, but A belongs to B. Yeah, that is false. Just let it go. This is done. Fine. Let us move on to the next problem. Let me, while you do the next problem, let me think of one more simpler example for this. See if I can give you a bit more clarity on this. But let me give you the next sum first. Let us move on to some questions on relations.
Sir,
Hmm.
could you scroll up once?
Yes.
Yeah. We're saying that A minus C is a subset of B.
Yes. If that
So,
happens.
huh.
Hmm.
And if that happens, then A is a subset of B. But then if we can say that if A is a subset of B and A minus C needs to be a subset of B, in that scenario, C should either be inside B or should be cutting through B.
Correct. And from our Venn diagram, that does not happen. C
Exactly.
can be outside, and without, if C is outside, then the conditions here will be true, but the final result will not be true. That is why this is false, because that is the one thing that you have to show, right? That the conditions are true. That means whatever you give in if, etc., that is true, but the conclusion, then that part is true. So here in our case, we could not reconcile that. Fine,
Yeah.
fine, works. Let me give you the next problem. Yeah, okay, so we move on to the section on relations. Try this.
Sir, I don't think I can recall. What is equivalence class?
Reflexive, transitive, symmetric. All three.
Right, right, right.
Is it option D? X square.
Yes, how do you do it?
It represents a circle of radius √2. That's
How?
why. Huh?
How? Your logic is correct, but how did you prove that?
If I put the value there, like 1 and -1, if I put it like x, if it's basically the equation of a circle. If I put 1, x is 1 and y is -1, then √x² plus y², I'm getting √2 as the radius and I square it. So the equation should be option D, right?
Fine, fine, fine. Others finish it.
I got the same thing. Honestly, I didn't expect it to be a circle.
All the options
I
are
did not
circles, right?
realize the fact. I didn't realize that fact.
Oh, yeah, fine. So this is not that difficult, but let us still do a theoretical solution. All right. That way, if I remove the options, this can be a very nice theoretical question as well. So how will you write it? So you will first take P and Q, right? P A comma B and Q C comma D. Then what would you have? So as OP is equal to OQ, right? So same distance from the origin, OP equal to OQ. So this will imply root over of A square plus B square is equal to root over of C square plus D square. Okay. So if you square both sides, you will just get the relation is just like I can write relation A comma B for any A comma B and C comma D. The relation is such that A square plus B square is equal to C square plus D square. All right. So this is a simplified version of that relation. All right. Now what will you do? So for any two more random points, since this is an equivalence relation, so if I take the points as m x comma y and n minus 1 comma minus 1, no, minus 1 comma 1, yeah, same thing. You can take 1 comma minus 1. 1 comma minus 1 is given, so let's take that. Why not? So 1 comma minus 1, that is how you calculate the equivalence relation, right? You take a random variable, not the probability one. So this, the variables and the actual class after you define the relation. The actual value that you are asked in the question. And then you take the variables, you put it into this relation, you should get your answer. All right. So that means as R is equivalence. So M would be related to N. Right. So that would imply x square plus y square is equal to 1 square plus minus 1 whole square. All right. This is how we will write the solution. So not only did we solve a MCQ type question, but also we knew how to write it down, which is quite important because sometimes you will have to write the things down in ISI exams because you do not know what in which of the sections will this appear in. All right, so we have done domain. We have done relations. One sum on relations. You will not find many questions on relations. So now let us move on to a question on functions. These are made as tricky as possible because functions will slowly lead to calculus questions as well, right? Okay, so let me find it. Yeah, do it. do check the order of brackets. Okay, so this starts from here and ends here. I'll give you a hint. Use trigonometric properties to expand those.
So is the answer in whole numbers or
Let me check. Hey, it's a range, right? No, it'll be in range. Okay, let us do this. So, does any one of you remember the trigonometric formulas of cos A plus B? You will need cos A plus B and cos A minus
cos A
B, right?
cos A, yeah, cos A cos B uh, plus sin A sin B minus sin A sin B
Cos
for
A plus
cos
B
A
is
plus B.
cos A cos B
Cos A cos B minus
minus.
sin A sin B.
Okay. And what about cos A minus B? Just the same
Same
formula
but
with the
positive
plus sign.
sign.
Use this. Should work, right? So cos 3 pi by 4 plus x would give you cos. Just forget that 3 for now. So you will get cos 3 pi by 4 into cos x minus sine 3 pi by 4 into sine x plus cos pi by 4 into cos x minus sine pi by 4 into sine x plus cos pi by 4 into cos x minus, right? So it will be plus now, plus sine pi by 4 into sine x and minus. So it will be minus cos 3 pi by 4 cos x minus sine 3 pi by 4 sin x. Check the cancellations. This is gone. Minus sine 3 by 4. This one is not gone. This one is gone. So you are left with cos 2 cos pi by 4 cos x minus 2 sine 3 pi by 4 sin x. What is cos pi by 4 is 1 by root 2, right? So this is basically root 2 cos x. What is sine 3 pi by 4? Yes?
Minus 1 by root 2.
Is it minus? It is pi minus pi by 4, right? Sine pi minus theta is positive. So this is also positive 1 by root 2. So this is just root 2 cos x minus root 2 sin x. So what you ultimately get here is fx is equal to log root 5 3 minus root 2 sin x plus root 2 cos x. Everybody agrees still here?
Sir,
Yes.
cos is negative in the second quadrant. So the first term should have a negative symbol on it, no?
But cos pi by 4. Cos pi by 4 is the first quadrant.
Right. Right.
Pi by 4 is 45 degree. Cos 45 is 1 by root 2. And sine 3 pi by 4 is pi minus pi by 4. So sine pi minus pi by 4 is sine pi by 4, which is 1 by root 2. So this will remain. Yes, anyone else? Any other queries from here? Or this part is understood? If this part is understood, then there should not be any other problem. So how will you calculate the range here? You know that formula, right? Of A cos x and B sin x. That I gave you the formula. A sin x plus B cos x. So this one is less than root over of a square plus b square, less than that, less than equals to root over of a square plus b square. If you check the notes, you will find that formula. So what will you have? You will have for range -2 less than minus root 2 sin x plus root 2 cos x less than equals to 2. Okay, I'm still writing the formula for those. This is minus root over of a square plus b square less than equal to a sin x plus b cos x. Even if you reverse the values, it won't matter. If you write a cos x plus b sin x, that doesn't matter. All right, this is the formula for range. So now I can add 3 to it on both sides. So I'll get 1 less than equals to 3 minus root 2 sin x. You can observe the answer developing now. Root 2 cos x less than equals to 5. What if I take the log root 5? So log, this will be 0 anyway, because log root 5 of 1, any log of 1 is 0. So less than our fx less than log root 5 of 5. This part is 2. So this implies the range of fx is 0, 2. That is your answer. Very nice problem. Mixing trigonometry, logarithm, function, domains, ranges, not domains, just range. All right. So these are the types of problems that we enjoy solving. Okay, because quite a lot of sections get revised altogether. Look into the solution, see if you have any doubts. If not, then this was the last problem for the day. All right, our time is up. Let me know if you have any questions.